Hey everyone, I'm Roger Borland from Borland Architecture, and today we're going to be diving into a topic that's really close to my own heart. It's Passive House. Passive House is a fantastic tool to set up the foundations for the project that fundamentally change how you live into the future and how the quality of that home will reflect a better future. So what exactly is Passive House? Well, today we're going to be getting into a little bit of detail about it so that you understand exactly how it works. So that whether you're designing a new build project or a renovation, you'll understand the principles and you'll understand how you can put these in place so that you'll create a better home for yourself and understand really whether this is a tool that you want to be using to reflect that future. You might have heard of Passive House before, and you may have some conceptions about it, and some of those might be misconceptions as well. So today as well, we're going to actually be talking about some of those and trying to debunk some of those ideas and create some clarity around the idea of what it is. See, at Borland Architecture, we're committed to providing you with the best possible information so that you can live in a more comfortable, healthy, energy efficient house. And that's what Passive House does, really. It sets the fundamentals into place so that you can do this for yourself. And we really want you to understand that and learn from it. So stick around, we're going to get into it, and by the end of it, hopefully you will get a lot more clarity around the idea of Passive House. So let's start with the basics. What is Passive House, and why is it considered to be the gold standard of home design? Well, when somebody asks me this question, I provide the following answer. Passive House is a design and construct methodology that allows us to design buildings to exacting standards. And these standards allow for energy efficiency, health, comfort, and well-being at its core. So let's break this down a little bit more. There are four key areas within that statement. The first one is the exacting standards themselves. So the exacting standards are both in the design phase and in the construction phase, and it happens the whole way through the process. And so it's ensuring that the standards that we're setting, which are to a very high level from the very start, are maintained and tested the whole way through the process. And whenever the building is handed over, there's a certification there to prove that those standards have been achieved. The second one is energy efficiency. So the principles of Passive House focus a lot on energy efficiency, and it's about reducing the energy load required for heating and cooling within the building. Often, some positions in the world not requiring heating and cooling at all, and so it's really reducing that load right down. Third part is that it's really comfortable. And so passive houses are famed for their consistent internal air temperature. So it keeps it at a stable temperature between 18 and 23 degrees all year round with very little need for heating and cooling. And so it's this stability within it that makes the house really comfortable. So you don't get those massive fluctuations that we are typically see in the traditional housing stock in Australia. And that leads to obviously a lot more comfort generally for the occupants. And it also therefore affects the health and well-being of the occupants as well. If you're comfortable with the temperature, your well-being, you're feeling a lot better as a person generally, and most of the time, because you're living in this house every single day of the year potentially, it's going to have a big impact on you over time. But what's more is passive house process ensures that the internal air is constantly filtered, and this ventilation system is removing the internal toxins that are in the building and leaving them back outside again so that you're not having to suffer from those. What's more is the building envelope itself is so airtight and so well managed that you're not getting the contaminants from outside air coming in and affecting your health internally in the building as well. You follow 5 key principles for Passive House. I'm just going to run through those with you quickly. So the first one is airtightness. And airtightness is a critical part of the passive house envelope. And when we're talking about passive house and with these principles, I want you to be thinking about the thermal envelope of the building. So this is the external walls, floors, and roof of the building. Not to do with your joinery, it's not to do with your finishes. It's got to purely do with this building fabric in itself. So the airtightness of this building fabric ensures that you don't get any drafts through that fabric, and therefore you're helping with the comfort level. It ensures that you don't get those contaminants from the outside coming through as well. And so these are key components just to help to manage the internal environment and keep it comfortable. Talking about comfort, the second principle is consistent thermal insulation. So this is critically important in a passive house because we go into a lot of detail on each of the junctions. So for instance, where we've got a floor to a wall to a roof, around windows, around doors, and so on. Those areas, it's very easy to avoid insulation in those areas and substitute other structure and services into those areas if you're not carefully designing it. And that can then, will definitely lead to a lower performing building. So in passive house, we're not allowed to do that. We need to ensure that this consistent line of insulation goes the whole way around the envelope of the building and doesn't have those services and structure in there that's going to impact this thermal envelope and making sure that it works in the best possible way. The third one is high performance windows and doors. So if we have got a really high performing and airtight building envelope and then we cut holes in it and we put windows and doors in, we have to ensure that those windows and doors are performing optimally, just like the envelope itself. And it's very difficult to do with windows and doors because they're the thinnest profile in the building. And that means that they have the least amount of thermal resistance to the outside air. So air or temperature can pass through that quite easily if it's not designed correctly. So we need to ensure that the windows and doors that we put into a passive house are of the highest quality standard. And that means that we may need to go for triple glazing in some instances. Other cases, we might get away with a high quality double glazed unit. But the frame of the building or frame of the window, and the frame of the door is a critical component of this as well. So that is the part then that connects back to the thermal envelope of the building. That needs to be really well sealed and it needs to be what's called a thermal broken frame. So it doesn't, again, allow heat to transfer through that frame. And so it keeps it nice and consistent with the envelope itself. The fourth principle is what's called thermal bridge free construction. So previously we talked about the structure being in that thermal envelope and how that can be a problem in regard to blocking the consistent insulation that might run around that structure. Well, that structure within there, if it's steel, for instance, is a thermal conductor. That means that it allows heat to pass through the building element itself very easily. And so that is a problem. And because we want to try and maintain the heat within the building or the comfortable temperature within the building. Could be the opposite. The heat might be on the outside on a hot day and cool on the inside. We want to make sure that we have a barrier between the two. And if this piece of structure is a thermal conductor, it's actually bridging between the warm outside and the cool inside, or vice versa, warm inside and cool outside. And we want to try and avoid that. So we need to design this structure very carefully so that it doesn't bridge those two elements or two environments. The last part of this is what's called a heat recovery ventilation system. So we've made a very airtight building. We've made sure it's really nice and cozy with this blanket of insulation the whole way around. We've got really nice high quality windows and doors in there. We've not got structure that's bridging between the two. The last thing we need to do with it is put a ventilation system in. And this works for a number of different reasons. One is that as human beings living in an internal space, we're constantly breathing moisture into the air. What's more is when we cook and we clean, we're usually creating steam, and that steam also creates moisture in our air as molecules of water. Those molecules of water have to go somewhere. They typically will follow the path, thermal path from cool to warm. So what can happen is if the building envelope isn't designed correctly, it can suck that moisture into the building structure itself. And that can lead to a degradation of that structure if we're not careful. And what's more is if it's allowed to go into that wall structure, it can create mold within those structures, and that has a massive impact on our health in the long term. And it's really dangerous because we don't actually know what's happening. It's happening within the building structure itself. So we really want to avoid that. The second part to the heat recovery ventilation system is that it is recovering the energy. So unlike a mechanical fan that is taking your damp air out of a bathroom and dumping that outside, what the heat recovery ventilation system does is that it takes that damp air and puts it outside, but before it takes it outside, it actually takes the energy out of it and recycles it back into incoming air again. So we're recycling the energy in the building and making sure that that gets reused again. And so it's an important part of the energy efficiency of the building. What's more is it also ensures that the health of the occupants is maintained at all times as well. And so it's constantly filtering the internal air, ensuring that you have the best quality air at all times, removing pollen, removing viruses from the air so that your internal environment is maintained at the right levels at all times. So that's the 5 passive house principles. Now, one of the main things that sets a passive house apart from a normal code compliant building is the level of energy modeling that needs to be done within the design phase. And so the building is modeled within a specific piece of software called the Passive House Planning Package, or PHPP. And this is a very detailed model that takes into account all the building elements that are required to go into this thermal envelope, including all the windows and doors, and breaking down all the components of all of those different elements and modeling every piece of those so that we ensure that the balance of all of the components that we put into the building is achieving a set standard. So that model then creates a virtual picture of what this building will look like, and we create our documentation to match that so that the builder knows exactly what they need to do. The second part of the process then is what happens on site, and that is the testing phase. And so we've got the model, we've designed the building very specifically so that it will achieve these standards. But we must ensure that the construction phase of the process actually aligns perfectly with that model as well. And so it's very important that the builder proves during the construction phase that that process is being adhered to. And so this can take a number of different forms. One is as the building is constructed, the building envelope itself is carefully photographed and documented so that the builder is telling the certifier, yes, we have achieved the details and here's the evidence to prove it. The products that are going into the building as well are typically pre-certified as well, so that we know that they are achieving the right standards and they're not allowed to be substituted. And so again, you as an end user of this building are ensuring that you're going to be getting what you have actually been promised in the design documentation. The next part that happens a couple of times, typically during the construction phase, is air pressure testing of the building. So this is where they put a blower door piece of equipment on usually the front door of the building, and it sucks the air out of the building to 50 pascals, which is like a light breeze typically. And the blower door itself will determine how much air is actually escaping out of the building in various other areas. And you can go around and find these little holes in the building, and you can seal them up using like a smoke test or something like that. And it does this, well, we do it in two ways. We do it, first of all, by sucking the building out, sucking the air out, sorry, and then secondly, by blowing the air into the same pressure. And so this represents what a breeze on the outside of the building might be doing to the building in certain times of the day, where you've got this breeze, how that impacts the envelope itself in regard to the air tightness of the building. And so it needs to achieve a very tight air tightness standard to pass the tests. And so it's the builder's responsibility to ensure that happens by following our details and then building it correctly. So as you can see, there's a lot more detail in regard to the testing and the modeling that goes into creating a building. And these two then have to come together and create a built product that actually aligns with the certification. And that is very different to the typical process in the building industry, which will have a model which achieves a certain standard, but then the construction phase is not tested to achieve and to ensure that that standard is actually achieved. So you as a building owner has no certainty that what you're getting in that type of scenario is the best possible building that you have been promised. So let's touch on some of the misconceptions that are out in the greater world about Passive House. So the first one that we often hear is that Passive House is too expensive. It's a very expensive process. And whilst there may be some truth in this, it has been well documented that passive houses can be constructed at a similar cost to a other high performance building. Now, it's very important to give this a little bit of context because a passive house is really, a very high standard building. It's comparing apples with apples. We need to ensure that we're actually doing that and we're not comparing a passive house with a volume built house. They're very different buildings. So the level of detail and the level of quality that goes into a passive house versus a volume built building, they're chalk and cheese. They're very different buildings. And so if you're buying a Rolls Royce, you expect to pay a little bit more for that level of quality over what you would be buying a lower range car. I'll not give any names. But this is an important aspect of it. Now, if you really want to achieve a high quality product, it's important that you understand that there are costs associated to it. And there are also ways of mitigating that cost and making sure that is within your budget. So something that we can all do is make our homes a little bit smaller. In Australia, we build the biggest houses in the world. It's prudent to try and look at ways of reducing the size of our building. And by reducing it, obviously, then we can put that cost back into the high performance passive house elements of the build. Other things that we can do is we can reduce down on the amount of bathrooms we have. There's no need for en suites to every bedroom, for instance, no need for walk-in robes for every bedroom. These things will cost a lot of money in regard to the finishes and the plumbing and the fixtures and fittings that we put into them. And all of those things are easily substituted back into the high performance side of it. The other side from the cost, the other aspect from cost is there's a lot of elements within a passive house that you do not require. For instance, you don't need as big a heating and cooling system as you would in a traditional built house. So underfloor heating systems, for instance, you don't need to put that in. And the cost of that is around about the equivalent of putting in the heat recovery ventilation system. So it's just moving the money from one area to the other. Likewise with the high performance windows. There's been tests done by some of our friends in the building industry recently that have proven that the high performance windows are very, very similar in cost to this typical volume built type frames that are out there as well. And so this misconception that these building elements are very expensive is not actually very true at all. You just need to find the right products on the market, and we can help you with that. This second misconception I want to touch on is, and often another one that we hear very common, is that these homes are too airtight. And it's not healthy to be in these homes because they're too airtight. It's like living in a plastic bag. The fact that we've got an airtight envelope does not mean that the air inside our buildings is being restricted in any way. So we have the heat recovery ventilation system that is providing exactly the right amount of air, and that air is perfectly filtered, it's perfectly fresh, and it's been put into all the right spots of the building at exactly the right rate. And so this system is ensuring that no matter what the outside conditions are, and no matter what the internal conditions are with the amount of people that are in the space, you've got the right mix of air and the right amount of carbon dioxide and oxygen within that mix through without the allergies and without the toxins that come with that typically. So it means that you don't have to open windows and doors, but you can open your windows and doors. There is no restriction on that at all. You can use your home exactly the same way that you would a traditional home. And so again, that's often a misconception that's out there that they're too tight and you can't open windows and doors as well. So it couldn't be further from the truth. Now, people think that, okay, if the power goes out, then the heat recovery ventilation system will stop running. Will you suffocate in the building? And, is it so airtight that it's like living inside a plastic bag and therefore that is a problem? Well, no, it's not either, because the internal space of our homes it holds a lot of air. It holds a lot of oxygen. You would need to be in that space for a very, very long period of time before you actually start feeling any effects of lack of oxygen or whatever. And if you did, you would start feeling drowsy and you would just open a window anyway, and then it would just act like a normal house. So there's no issue with that whatsoever. The last misconception I want to cover off is this idea that a passive house is too complex to build. It's very expensive and complicated, and you have to have dedicated teams that know exactly what they're doing. Okay, so whilst there is an element of truth to this, it comes down to education. We need to ensure that the people involved in building our buildings anywhere, no matter what sort of building it is, know how to build the buildings correctly. And we want to try and educate them to build them in the best possible way for the future. So all Passive House is doing is it's raising the bar in regard to that quality and detail. And so we can very easily teach the designers and the tradespeople and the builders and all the end users, everybody involved, on how to build and live in a building of this type. It's not overly complex. The principles are actually very simple, the 5 principles that I pointed out earlier. If you understand that and you understand how those principles affect each of the different details in the building, you can quite easily design that building. There is lots and lots of information around at the moment and lots of fantastic professionals around that can help you to achieve this without any penalty in regard to the complication of how the build happens or the period of time it might take to build. So what do you think? Are you ready to move into the passive house space and design yourself one of these high quality buildings? Well, we'd love to hear from you if that is the case, but ultimately, I hope you really enjoyed this video. You got something out of it and a little bit more educated on what a passive house is. And you can also answer some of those misconceptions that are out there in the market. If you found this useful, please like and subscribe. Share it with somebody else who you think might be heading down the route of building a new building and would learn from this as well. We'd love to hear from you, so drop in a comment. Otherwise, we'll see you on the next video. Thank you.